Yes, perfect. Okay, awesome. So thank you for choosing this talk. There were some amazing ones plus the expo. So thank you very much for attending here. I'm going to be talking about how we've built a cloud-based scalable mobile lab for automation at King and the whole journey that has been going with it. So let me first introduce myself. I'm Laura Martinez Anauja. You have there my contact info, but you will have it at the end too. I'm a computer scientist with a master's in artificial intelligence. I've been working for more than 4 years as a QA automation engineer, either in browsers, chatbots, within the ticketing industry and also the gaming side. And for these last 2 years, I've been working at King as a tools engineer, and I'm especially doing tools for automation, which is what I will explain today. So just for knowing a bit more about me, 3 fun facts. I'm a violinist and a singer. I used to play the violin in the Catalan National Orchestra, and I actually sing in 2 choirs. The one under the arrow is me in this last production that we did this May. I love games of all kinds. I love playing video games, but I also enjoy a lot board games and escape rooms and everything that brings fun to my life. And I have 2 lovely cats, Domino and Gustavo. Domi is the most loving cat and loves cuddles in the floor. And Goose has the loudest voice I've ever heard in a cat. And he likes to announce his presence. So if you have a call with me sometime, you'll probably hear him around because he doesn't stay still. And a bit more about King. So I think that most of you will know this, but let's do a hands-off. Who here has played Candy Crush? I mean, come on. Most of the room here has played it, and it's normal because Candy Crush, it's been for the 19th quarter, the top grossing game franchise in the United States. So around the world is super well known, and everybody has played it. But in King, we have many other games. We have 13 live games, 14 if you count the Rebel Riders soft launch this last month. So we are maintaining this, and the first game was launched in the social networks in the second quarter of 2011, and it wasn't until the second half of 2012 where King started the mobile industry gaming side. Some facts about King. On this first quarter of the year, we've had over 250 million monthly active users, which is quite a lot. And to support that, we have a lot of teams and especially a lot of employees. We are over 2,000 people in the company, and we have 10 locations where we have our offices. So let's talk about the topic, about how have we built this cloud-based scalable mobile lab for automation and the whole path within it. So I'm first going to summarize a bit the ecosystem that we have inside King in the automation side and the games. Then I will talk about the history and the first approach that we've built and how we've evolved from that. Then why we needed this middleware and not going for another approach. How have we set it up? The latest challenge that we have had to face. What's next for us, and some conclusions. So about the ecosystem, it's quite complex, so I summarize it here in one slide. As I mentioned, we have 13 live games. Those are supported by more than 9 game teams around the world. We are using a custom C++ engine plus Unity for the latest games. We have 2 different automation frameworks, one in Java, that it's named Automato, and one in Python, which is Automation Client. The reason for having 2 is that in 2016, where the automation boom started within King, there were different people around the world who wanted to do something similar, and there was not a good connection right then. We didn't have much knowledge of working from home and from remote locations. So they started developing exactly the same, but in 2 different languages, and now we have to support them both. Also, games are done in many, many languages, just to name a few: Java, Python, C++, and C#. But also, King is complex because we have many phones that we want to maintain. We try to work with all mobile devices that are currently working right now, and also most of the mobile OS versions. For Android, we're holding from Android 5 till the latest, which is 12. And for iOS, from the 10th to the 15th. It will be 16th soon, but not yet. And for that, we have to build different artifacts because they differ in the architecture that they hold, in the environment. This is important because the automation is only run in the QA builds. You'll see why in a bit. And also some platforms, because we are having Android and iOS for mobiles, but we are also holding these games in Windows, in Mac OS, and Amazon. So it's quite complex. And if you turn everything of this into automation, it gets complicated. So the first approach to doing automation was actually before 2016, when this boom was starting. There was an in-house device farm, to say so, and it was held per team. So each of them had a drawer that had the devices inside, and they were connecting these. So in terms of running the tests to this device farm, to say so, they had their tests, they put them together in a zip, they uploaded that to a Jenkins job, and this Jenkins ran in a Mac Mini slave that run actually the connections to the devices and then run the tests in there. But let's make it grow. And it's not working for us to have one drawer per team with a small set of devices. We have to test in all of them. So we had to grow in terms of scalability to have more devices and more teams with having this available, but also centralization, because each of the teams started doing different things, and we didn't want two new frameworks to appear just in order to test. So this is how the King's Device Cloud was created, and I'm gonna talk about this, but I want to show you this video, so I have it on this side. Okay. So the King Device Cloud was an infrastructure as a service platform designed to be used across the kingdom. It had a UI, it had an API, and it had also Jenkins CI integration. It was distributed yet centralized, so the core was in a rack, as you are seeing here in the images, but all the teams across the kingdom were able to use it. It was scalable because we needed only to connect different devices to this rack, and that was it. It had concurrency, reporting, it had also metrics, as well as real-time screens. As you can see now, you could see them, but you also had them in the UI, and also real-time logs, which was amazing for the developers to be able to see what was happening inside the phone. And within that, there were some other things added, like having coverage. So in the rack, you are seeing there were, at the end, more than 100 mobile phones connected. And, well, you are seeing a lot of tests being run there. Let me go back to these slides. Okay. So this is how it looked like. This is the UI, where you see how the tests are running and how the device is working with the tests. And this is a super quick summary of the infrastructure that was behind. So it was basically an API where users, automation users, ran their suites. Then there was a broker who read from this API and then distributed it to the device cloud. And the device cloud managed the connection with the devices and everything. If you have interest, there's here a link where you can check all this information at. And thanks, that's the presentation. That would be a wrap, because this is actually a middleware that was created in King in order to do automation. But everything that goes up quickly can go down quickly as well. So there were some downsides within this device cloud architecture. Mainly costs and resources. That was the worst part of everything, because it's only the cost of the devices, the connection of them, maintaining. Then there were some infrastructure challenges, like cooling systems that had to be in place for the rack to be available to all the users all the time. There was also maintenance issues, like devices, batteries blowing up sometimes. some stability issues as well of the connections on the hardware per se, and also network challenges because the 100+ devices that were connected here were routed to the same distribution point of the network, and that caused sometimes some latency that wasn't expected. But also in this period of time, we are talking around 2018, King moved from one Barcelona office to another one. So it was within Barcelona, but it was a huge carry of things from one point to the other. So there were some other things arise, like the need of a dedicated room to have this infrastructure with all the racks and the devices, but the cooling system as well and everything. Also, the King was moving to externalizing solutions, and this was not possible to be externalized because we couldn't move one side but not touch the other. And especially this was the decision point. The team that was in charge of this solution started having other priorities, so there were no maintenance anymore from them. So in mid-2019, there was a gathering of the requirements from different teams that do automation in King, and they did a POC with several vendors. You can see here a summary of what was decided that needed to be done and the solutions that were checked. And in August of 2019, Amazon Web Services Device Farm was the solution selected. At that point, it had only 26 devices, and it provided great things, like it was external, so there was no need for a team actually checking and maintaining this solution. The devices were private, so it didn't impact us in the terms of finding a solution of builds that are still in the QA stage but not released somehow. Also, the availability to have remote access, not only for automation users, but also for the manual testers as well. And it also added something super cool that was network simulation, because they could test actually how the game would perform under different latencies on different games. And it also maintained the structure of uploading the zip to Amazon, and Amazon was in charge of everything else. So no need to change that either from the teams. But King is a data-driven company, and we lost some things on our side that were needed somehow. First of all, the control of, I didn't show the mice here. The control of the executions was taken care of by Amazon, so we did not have any control over where they happening and to which devices. Also, some statistics of usages of devices and so on. The devices started to be flaky somehow, so teams decided to allocate devices to themselves. So we were having, again, this drawer that I showed you at the beginning where each team had its own devices. So it was not ideal. And also, the device farm is not Amazon's main product. We all know them for many other stuff, but probably not for the device farm. So some teams at King started thinking, okay, device cloud, we miss you, we need to find another solution. And this is exactly why we built a mobile automation middleware. So in March 2020, our team was created. We are the innovation and development team inside King. This is the last Thursday because we do always a hat day daily. So all Thursdays, or since the beginning, we do a daily with some hat or some hat filter just to have a bit of fun. Because if you see the date here, we are a pandemic team. So we've been created automatically online and we've met few times since then. So our team took responsibility over the device farm. And the first thing that we needed was understanding the requirements. So we gathered all the requirements listed from the previous POC plus all the requirements from the teams, and we listed them. Here you have a short list, like reporting tools, having a live stream to be able to see what's happening in the devices while we are testing, security for the QA builds, network emulation, metrics. But we also had some game automation specific requirements. And this is, for example, Automato, which is the framework that we have in Java. So we understood a bit how they work and how are they built. And the first thing that we noticed is that we actually need an Appium connection for connecting to the devices. So from that, we gathered a list of general requirements that the device farm of our choice at the end needed to have. So it had to have Appium sessions, support for us to connect to those Appium sessions and use them. We also needed to install and manage apps. That's, of course, a given, but sometimes it's not. We also wanted to connect multiple devices because there are some tests that require multiple devices to be connected at the same time to test some features. We also wanted device connections and timeouts to be handled by us. It's easy to say, but sometimes it's not that easy to get. And we also wanted to run multiple commands in parallel. Some of the games, what they are doing is they are actually running a log cut to see the log of the device and what the device is doing, but also the actual automation action that is happening behind so that the test responds. And finally, some monitoring. But if you see here, this is the exact image that I put before. There is also one other connection. So this connection right here is a connection that goes directly to a game automation server that is inside the builds, because our games are built with a custom engine. So this custom engine doesn't allow us to work only with the Appium-based typical connection between a game and so. Actually, our engine, what it does is renders the screen on the phone, but not the actual elements. So we are not able to connect to the elements directly. That's why we need this connection to the automation server. This is only in the QA builds, and this is why we only run automation on those. So what we needed from this is to have a stable virtual USB connection. This allows us to route the traffic between the host that is running the tests and the device where the engine is actually rendering the instance, in the game. And then what we did is add a requirement for the device farms, and they must have a virtual USB connection. And especially this connection needs to have broad support because of the many versions and languages and tools and OS that we support from King. It also needed to have a stable connection and a short response time. It couldn't add more latency to the tests. It, if possible, needed to have backward compatibility because when upgrading one version of something, it's always a nightmare. So if it can be done automatically, we'll go for it. And finally, it needed to be able to be managed from either command lines or API calls or something similar, so we could add it to our middleware. So between the second quarter and the fourth quarter of 2020, we did a market analysis of several vendors. Some of them we discarded right away because they didn't have this virtual USB connection, so we were not able to use them. But we finally saw why this middleware was needed. So all the device farms that were left from this analysis did only the part of handling the devices and having them in a rack with the cooling system and everything, but not actually having the system of running the test to a specific device and connecting them to those in the way that King needed to be done. So in this middleware, we needed device connections. We needed to manage the executions and where they went sent to. We wanted to have the shared pool of resources, not to have teams allocating it to themselves. We wanted also to have custom usage metrics. We wanted to have full control since the user sent us the automation test to run up until we gave them the status of the report. And we also wanted to maintain the smooth transition, so maintaining the zip format that I mentioned before. And this is how GOAT was born. GOAT stands for Grouping and Orchestrating Automation Test Tool. And its requirements were, or still are, to be a centralized system. We wanted it to be also modular and scalable, to be able to build over it. We wanted it to be device farm agnostic, to connect to several device farms if needed in the future. We wanted to have management both from the executions, but also with the devices connection and how this interaction was built. We wanted users to be able to connect to it through API calls, nothing fancier. And we wanted to maintain the smooth transition, both for the zip format, filing way of working, but also compatibility with both frameworks that we have in-house. And finally, add some tracking and metrics that were going to be helpful. So how have we set it up? First off was deciding whether to put that in cloud versus on-prem. King has moved to the usage of Google Cloud Platform. You can see the link there, all the information. And therefore, we started already thinking, OK, cloud sounds good. King is moving everything there, so let's start with that. And at the moment, there were only Windows images created, so we went with one of those. But we quickly realized that iOS cannot be connected to Windows images. So we said, OK, so we maintain this Go for GCP with Windows for the Android ones, but let's do on-prem for for iOS, because we have already the machines there and we can use it. But this actually added a lot of complexity in terms of having two systems and maintaining two different things. So finally, we went with Debian, Linux distribution, and to make it even less heavy and easier for us to maintain, we only had the command line part, but without the graphical interface or anything. And with that, we were able to connect both Android and iOS. And for iOS, we had to use the Libby mobile device library. So this happened to be a new requirement for the virtual USB. So it had to be compatible with Linux to somehow, as easy as possible. And also to not require graphical interface, because some of them require UI to start the connection to the device, but we couldn't have that. And in the third quarter of 2021, we finally released the first version of Goat. The first part that I'm going to talk about is the smooth transition. So this is what it looks like for the users. They have to upload their automation code tests in the zip to GCP storage. There's an API for them to do so super quickly. And also they can upload their app to the storage as well. But there is another way of having apps in King. We call it the King App Store. So we have there all the builds that are created every night. And they could directly get that link and send it to us. So to send to us, they have to create a JSON format file, which has the zip URL, the app URL, the user info to be able to connect to the devices, and finally the devices info where they want to run the tests to. And that is sent with an API call to Goat. And this is how Goat looks inside. So as I mentioned, we wanted it to be modularized and to be centralized. So this is exactly what we achieved. There are two APIs for the user. The first one is the GCP part where they can upload and download their tests, but also download the output of the test and the whole status. And finally, and also the execution API where they can send the execution and then retrieve the status of it. And Goat inside, what it does when it receives an execution, it first passes to the test info where we validate all the values sent to us, and we move it forward to the allocator, which sequentially allocates each of the executions, not to skip one to the other. And this goes to the executor, where it's actually where the tests are executed, are run. And all of this connects to the devices module that at that moment we had Perfecto as our device cloud. So in the third quarter of 2021, what we were able to achieve? So we were able to run tests. Yay. That was perfect because that was exactly what we were required. But we were only able to connect one device at a time. So we had no concurrency. And with only Perfecto device farm, because that was the contract at that moment. So we did not have multi-device farm. We were able to upload apps from either, to work with apps from either the GCP storage that they were uploaded by the users or directly from the King App Store. We added also filters for the users where they could decide on a device depending on platform version, model ID, some others that we have. Users could use an API to trigger executions and to check status. That was the basic requirement. But we also added some other things, like, for example, requeuing. When Goat stops or when we need it to stop to upgrade the version, we need to go to pick the executions that haven't been run back and with the same ID and everything so that users can check still the status. We also created the iOS dummy apps and put them in all iOS phones to have the certificates trusted. We created as well some CI Jenkins jobs where other automation users could get those and use them as examples. We created different environments for us to test, develop, and release finally to the users. And finally added SSO so that users within the kingdom only had one user to access to all the platforms. So this is the same slide that I showed you before, and to see if we achieved it or not. So as you can see, many green ticks, awesome. We had a centralized system. It was modular, but not scalable because we did not have concurrency. It was the device farm agnostic. Since we only had one, it was not created with that in mind, at least. We were able to manage executions and devices connections. We had the API, also the smooth transition. And we had tracking and metrics, but actually not automatized. So it's a manual effort. We can check in the database all the connections with the devices and so. But that was working great. Users were super invested in that, and they started using it. But the more and more they started using it, it started going slow. It started taking a long time in the queue to actually run the tests. So we were asked over and over between surveys, direct messages, and everything to have concurrency. And this is actually our latest challenge that we've been working on up until this late month. So the first thing is scalability. For scalability, what we've actually done has been only changed in the devices module. You can see now that instead of Perfecto, we also have SauceLabs. And within this change, we've added many more functionalities. So we have the possibility to add more devices if we want at some point. We have been able to add some new filters for users to specify either the device farm or, for example, the architecture of the device that they want, because different vendors provide different values of the devices. We have added the logic to select the best device, keeping in track all the filters that the users are specifying, plus what we have available, and then giving them the first device that is available within these parameters, and the possibility to connect multiple devices at the same time. This is Q2 of 2022. And for the concurrency, it's true that having the possibility to connect multiple devices was actually helpful, and we could go with it for the concurrency as well. But what happens if the device, if the virtual USB connection, for example, gets broken or somehow it gets lost? So it was something that was implying that different tests were affected by others. So we said, okay, let's fix it from the hardware side of it. And instead of having one big server with all the modules inside, let's extract the executor server, the executor part of the server, and put it in different VMs. This has allowed us to have dynamic creation and deletion of instances that only are in charge of connecting the device, running the test, and then throwing it all to the trash to not have any collision between them. We are environmentally friendly in terms of trying to fit with the best solution. So we are working with low emission servers in GCP. We are also handling where executions are sent from Go. So we are both keeping track of the instance and then running the test to that. And for the dynamic creation and destroying of the instance, we have been using the instance template feature in GCP, where you just put the parameters and you run with it. And this allowed us to have these atomic matches where no tests are impacted between them. And we've achieved that without needing anything to change for the teams. But we maintain the sequential allocation of executions because we've had some problems where one execution was between the other, and so it was complicated. We maintain it sequentially in the location, but we have concurrent execution of the test. And the limit of that is the amount of devices that we have available. There's actually no other limit because we can spin up as many instances as needed for the execution side. So as you can see here, the requests get to go, sequentially they are allocated and then executed again concurrently. So I'm almost finished. What's next for us? First of all, we want Go to be an internal collaborative platform. It's a middleware that is used by many, many teams inside King. So we want our team, the innovation and development team, to maintain the ownership of work, of Go, sorry. We will be maintaining it and maintaining the instances and everything and doing, of course, feature development. But we want the automation guild at King to actually be able to collaborate with us, either with helping with new features because they are developers, automation, but developers at the end, and also with surveys to decide priorities and what's more important to come next for Go. But also we have many, many features already thought. We are already starting with the first one, queuing the executions per device. This is a way of trying to reduce the sequential allocation of the executions, but actually working per device. So we are working on that. We have also started on some UI. We've been doing this in some hack days, and so far so good. So we hope to have it someday soon. But there are many others, like having an endpoint for users to stop their executions, monitoring, having a better output with more information for the user, upgrading tech versions because it's only been 2 years or not yet, but we have to work on that as well. And if possible, more device farms. But the main objective is we will keep making Go grow, and that's the idea behind it. So I'm almost finished. What I hope you take away from this session is that there are many, many, many variables to consider when working with automation, especially with automation of mobile games. There are the many devices that you have in the market, models, versions, platforms, but you also have different automation codes from different frameworks to different set of tests that they are running. And you need to make sure that you're on track to achieve your goal. It's easy to somehow derail, to test some other cool features, but you have to focus on what you are trying to achieve. So the main thing is revisit your requirements. Don't be afraid to ask why we are doing this and what are actually teams needing from us. It's as easy as asking someone. Talk with the end users, and if possible, walk in their shoes. What we've been doing right now is also having a set of tests on our site. So we are developing LAM, which is the goat cousin, which has some automation tests that run the small tests that are available for all games, like, first of all, starting the game. That would be the first. Okay, I got the notice. And finally, don't be afraid of trial and error. It's true that you have to be conscious of your main goal, but sometimes it's nice if you can check different stuff because you will probably be surprised that it works better than you thought. So test the limit of your solutions. Go nuts with it and have fun. And finally, as the meme says, improvise, adapt, and overcome. Thank you very much. I think we have some time. I'm not sure because I don't see you so well. But if you have some questions, just ask. I will be around for sure those days, so just also come to me and ask whatever you need. Any questions? Sure. 1 second, the mic is coming.
Thanks for the presentation. It's amazing because automation is quite a challenging job in the market. My question is, in the Asian market, there are maybe thousands types of Android phones, especially in China. How to cover that with your device farm?
Yeah, well, if the device farm has access to those phones, they just need to connect them, as far as I know. But actually, we only have to connect them, and that's it. The games are what it's actually running inside, but for us, it's the same as any other phone.
Okay, great. Thank you.
Yeah, thanks. Anything else? Either no question. Okay.
Hi, I'm looking at setting up automation for our company and don't really know where to start. But are you all developers, or would you say?
In my team, you mean?
Yeah.
We are all developers. We are tools engineers, but we are actually developing a middleware. So we are more developers than anything else. Yes.
Thanks.
Okay. Something else? Yeah, right here.
Hi, thanks for the presentation. It's very cool stuff, and it looks like a lot of work. I'm wondering if you have tried to find any solutions of middlewares out there before you decided to build your own, and what were the downsides why you didn't use them?
Yeah, in fact, one of the solutions was Amazon Device Farm. What was not working for King in this case was the lack of control over where was everything executed and so on. And while we did this market analysis that I showed there, we were not finding any other solutions as for that moment. I'm not sure right now if there are many others. It's been 2 years since the analysis, so it could happen. Sure. And right on your side, yes.
Hi, I was wondering, with your kind of focus on physical devices, are there any projects where you're running into limitations where you're testing like massively multiplayer stuff, where you need maybe emulators or something like that to achieve those sorts of numbers to like really hammer that stuff?
I think we are not trying any emulator. I'm looking at my manager just to confirm. No, we are running on real devices. It's actually better for the checks on the, yes. So actual checking the game for as a user rather than an emulator, and we don't need to run on many devices at the same time, so we don't have this limitation of usage of them. Yeah. Awesome. I think that's it. Perfect. Thanks a lot for your time, and do not hesitate to contact me or find me around these days to speak about anything. Thanks a lot.